Okay, so I was discussing AST, you will get from this equation mu 0.87 Fy into Z. Now your AST would then be, what is your mu given in the question? How much was the mu given in the question? Your value of mu was 800. So 10 raised power 6 to convert it into Newton mm divided by 0.87. Now your Fy, what is the value of Fy? Fy is 415, and your Z, if you are taking the lower value of Z, it would be 200. The higher value of Z, it would be 200. This is an approximate value. Now, can you get AST value here? Just calculate the value. Am I audible?
Please continue.
Okay, okay. So कितना आ रहा है ये the value of AST?
Sir, is that 600 है या 200?
It's 10 raised power 6. Because this is in kilonewton meter.
Z.
Z is 200.
Continue.
So it's
600 निकालो.
798 ये आएगा.
Sir, Z हमें ऊपर 600.
It is 600.
निकला ना?
Okay, 600. Sorry. This is 600.
निकला ना?
Sir, that 600.
600. This is 600. So you are getting this as 3692.93 mm square, is it? This is what you are getting. Have you also checked?
Yes, sir.
Yes, sir.
So we'll be providing the bars now as per this requirement. Let's provide 4 number bars of what? Say for example, we are providing 25 mm bars. Let us first check. If we provide 25 number bars, the area of each bar would be 3.14 divided by 4 into 25 square. This would be कितना आएगा? This is 490 mm square each. Is the area of each bar. Now, how much do we require? So you cannot provide 4 if you are providing 25 mm bars. So we will have to provide number of bars. कितने provide करने हैं? It's 3692.93 divided by 490.625. कितना आ रहा है? Eight bars.
7.5.
So that's around 8 bars. we have to provide. If we are providing 25 mm bars, but adjusting 8 bars in a 300 mm span, that would be quite difficult. So we can go for a higher 32 mm bar. Then the area of each bar would be it would be 803.84. So then you would need to provide 3692.93 divided by 803.84. So that would be 3692.93 divided by 803.84. So that would be 4.59. So that's around 5 bars that we need to provide. Am I audible?
Yes, sir.
There is a problem of internet connection here in Avantipura. So we have 5 bars being provided of 32 mm is the dia of each bar. So why do we provide these bars? We could provide it something like this. 5 bars in this fashion. Bar 1, bar 2, bar 3, bar 4 and bar 5. Because this overall is just 300 mm. So you have to fit these bars within 32 mm, 3 bars in one row and further 2 bars in the second row. So these will be the tension bars that we are providing in this. But is it actually what we require, or is it lesser that we require? Because this is based on assumption that the lever arm is around at the center of the flange. This is on that assumption. Or you could have taken another assumption that lever arm is at 0.9 times Z. But is this what we require? That we have to check. So for that, we will be determining the actual area of steel that's required. Determining the actual area of steel. Now, what is your XU max? By D equal to, for Fe415, it is 0.48. So your XU max is 0.48 into D. What is D here in this question? Are we aware what is the value of D here in this question now? The actual one now, after the assumptions have been done. That would be from here till where? Can you now check till where is your D now? Your D, is it till this point, center of these bars? Or is it at this point? Here or is it here? Yes. Anyone? For the sake of simplicity, what we'll do is that we'll take it somewhere here. Or otherwise, you could have taken at effective depth between the center of these. But we'll just simplify it. We'll take it at this point, because then there you have only 2 bars and here you have 3 bars. So you cannot take the center of between these two bars. It would be more inclined towards the bottom bars. So thereby, we'll take till this position. Now, if you have cover of to this beam, you have cover. If you have the cover and you are providing the cover of, for example, let's say कितना प्रोवाइड करोगे आप इसमें was there anything given moderate exposure दिया था in the question? So in moderate exposure,
Yes, sir.
No, sir.
moderate exposure, how much do you have cover? Just check for the code.
Yes, sir.
जी,
Sir.
how much is the cover for moderate exposure?
हम लेते हैं ना सर
30 mm. Then stirrups, there will be stirrups. Let's assume that to be 8 mm. And then you have these bars, which are the dia of these bars is 32. So let's take it at 32 by 2 itself. So what would be D? Now let me write it here. D would be, this total was 700 till this point. So overall depth was 700. So it would be minus 30 minus 8 minus 32 by 2. Or tell me what is it? How much is this?
646
646. Again, I have simplified. Otherwise, you have to take it in between these two. I am just simplifying this. So this is 646. 0.48 into small d. So how much does this come? 0.48 into 646.
310.0
300? कितना?
10.08 310.08
310.08. Now we have the value of XU max. Now, why is XU max required? If you check the code, what we did last time, there you had a clause. Just a minute, I will open the code. So in annexure G, you had this mu is 0.36, xu max by d was the equation when d by 2 d did not exceed 0.2. Now we require the value of xu max first to know whether this formulation is being accepted or not. So we had to check what is xu max first and df. Then we can apply these equations. So your XU max is now कितना आया हमारा अभी 310 right? यही है. So your
Yes, sir.
DF is 100. Your DF is 100 mm. Then your XU max is greater than DF, right? Your XU max is now greater than DF, which is 100 mm. Thereby, which condition does arise now? The condition that arises is your XU, if XU is equal to DF, because overall your XU max is now greater than DF. So your XU can be equal to DF. Then it has to satisfy which XU is less than or equal to XU max. It has to satisfy this for under reinforced design, whereby your XU can be equal to DF. Now we will be assuming here, not assuming, we already have that given in the question, that your grade of concrete is M25. So your FCK is 25 megapascals, right? Thereby your moment of resistance now for the section, what would that be now? The moment of resistance for this section, if your XU is equal to DF, क्या होगा? Can we check? Can you check from the code? When for the moment of resistance may be calculated when your XU max is greater than XU is greater than DF, which is the condition arising here. The moment of resistance may be calculated by equation given in G 2.2 when DF by XU does not exceed 0.43. Now at this moment we don't know the actual value of XU. We're just assuming that DF by XU is DF is equal to XU, so DF by XU is equal to 1. That's what we are assuming at this point. We're assuming that DF by XU is equal to 1, जो कि आपको यहाँ पर दिया हुआ है from this. Your DF by XU does not exceed 0.43. If it does not exceed 0.43, then you will be using G 2.2. This is this one. But if it exceeds, when it exceeds 0.43, in both cases, substituting XU max by XU, then you just need to substitute in the same equation, in this equation, G 2.2, this equation you have to use, and you have to substitute it, XU max by, substituting XU max by XU. That's what you have to do as per code. So this is as per code that you have to follow. Now, thereby, what will be the equation that you will be using now? What is the value of mu? What is the equation as per code? It's 0.36, right? XU max. Just check from the code, which I was just telling you, into 1 minus 0.42 XU max by D into FCK into BW D square. This is one part of the equation, plus, I'll write it here, the other part, plus 0.45 FCK BF minus BW into YF into D minus YF by 2. This was part 1 of the equation, and this is part 2 of the equation. So at this stage we have the value of many of these entries. XU max, we know what is the value of XU max, so we can now solve this equation. So first of all, let's get the value of XU max. That's known, 310.08 mm. What is the value of D? कितना है हमारा अभी? Can you just recall? What is the value of D? Yes. Yes, somebody 500 or 600 something?
646.
600?
646.
640.
46.
Okay, 646 mm. Then FCK, it's 25 mm. Then BW is what? BW is the width of the web as 300 mm. Then B, it's known. Then in this portion, part 2, FCK is known. BF is 1500 mm. BW is same 300. YF, you need to calculate. What is given, the equation of the YF that's given in the code is this. YF. Is it visible here at the top?
Yes, sir.
0.65 df. This is the equation of YF given in the code. But for that, you now require the value of XU. It's 0.15 XU plus 0.65 df. Now for that, you require the value of XU. Now, how do you calculate that value? Other values are known to you now for this equation. D is known, everything else is known. You just need to now determine the value of YF. But for that, XU has to be known. Now, is it known to us XU right now? We were just assuming that our XU is around equal to DF. But it could be XU could be greater than DF as well. We never know what is the actual value of XU. So now what do you think what we should do? How should we get the value of XU here now? We have gone through all these approximations and assumptions till now. Yes. Yes, somebody? Ji. So let us first calculate this part 1. Can you get the value of this? How much this comes out to be? Let me write it down here. This part 1, इसका value कितना आ रहा है? This is 0.36. XU max by D is, it would be 0.48. 1 minus 0.42. You are not focused on the lecture. I just told you something. Can you recall what was given in the code? Your D value is 649. 49 or 47?
46.
46. तो कितना आ रहा है दिस फर्स्ट पार्ट का इसका वैल्यू कितना आ रहा है जस्ट कैलकुलेट Yes, 600, 668,433.254. This is an mm, right? So this is Newton mm. This is coming to be Newton mm. यही आ रहा है Yes, somebody? कुछ और भी है इसमें BW, so it's D square, sorry. It's 431,807,882 Newton mm. So that would be 431.8 kilonewton meter. This is part 1. Now coming to part 2, this one. Just remember this 431.8. This is part 1. Now in part 2, it was given in the code right now that wherever you have XU, you have to replace it by XU max. When you are assuming that XU is equal or almost equal to or greater than DF, then so when your XU, it was given in the code, when your XU is greater than 0.43, right? When your df by xu is greater than 0.43, then you have to assume that all values of xu are equal to xu max. So even here for yf, you will take this as xu max. Again, this is based on assumption. The code itself is based on assumption because this is a hit and trial method. So the value of xu max was kitna? 310. इतना ही था 310.08 0.08 था
Yes, sir.
plus 0.65 into df was 100. तो इसका वैल्यू कितना आ रहा है? $111.512 mm is the value of YF that you are getting. So your this value part 2, how much would that be now? If we are determining the value of part 2 of MUR, it would be 0.45 FCK. FCK is now 25 into BF is 1500, BW is 300 into YF is now 111.512. Your value of B is 646 minus 111.512 divided by 2. So calculate this value. This is 1505412 into 646. That's 590.24. So this is coming to be 888.56 kilonewton meter. Up to this point, it was in Newton mm. I converted it into kilonewton meter. So it's 888.56 kilonewton meter. So overall, what is the value of MUR now that you are getting? Yes. कितना आ रहा था? पार्ट 1 कितना था?
$431. 0.8.
and part 2 is 888.56. So total is how much? हाँ जी कैलकुलेट करो. That would be 1320.36 kilonewton meter. Now this is the moment of resistance of this section. Although we have used certain assumptions like XU, we have taken as XU max, we have used that. So, but this would be always greater than आपका load कितना है 800 kilonewton. Factored moment for which you have to design is 800 kilonewton meter. So this is always greater than that. So you can then it is clear that your DF which is 100 mm is less than XU. Your XU is how much now? What have we assumed? It is around XU max. It's less than XU max. It's less than XU max. It is clear it's less than this because this is an under reinforced design. Your moment of resistance is greater than MU. That means your MU is less than MU limiting. So it's an under reinforced design. Thereby your XU will always be at the center of this section. So it is less than DF is less than XU. And what is it still less than? It's less than XU max. So we can say, we can again solve what we have already done is that we have already calculated the value of AST for this section by an approximate method. Now you could yourself revise this. If this is now proven that your 1320, this is greater than 800. So you can assume that it is even lesser than this. How? You use XU max in that question, which was the overall, उसमें resistance आ रही है for total XU max. You replace, but for in that case your XU was DA by XU was greater than 0.43, which you assumed. Thereby, जो आपका इसका compression would be still in this flange. The center or the neutral axis, it could be, will it be in this flange or will it be here? It will be somewhere here. It will not be in the flange. And your DA by XU it is sorry, it's in the DA by XU is greater than 0.43, but it is less than, it will be less than 1. So your DA by XU will be less than 1 because you do not require this much amount of force. So you will keep XU outside this. Your DA by XU will be less than 1, but it will be greater than 0.43. So you can revise this question, and what you can do is that you can treat that you आपने जो lever arm, now how much would be the lever arm now? Can you now check how much would be the lever arm? If it's at the center of this, we'll try it to be at the center of this, and that will solve our problem. So वही हमने किया in the first approximation, and we have checked that कि वो approximation सही आया हमारा. There was no need of additional requirements. So जो हमें निकला, the amount of area of steel जो हमारा आ रहा था, कितना आ रहा था? Some कितना आ रहा था? We do not need to revise this. हाँ बताओ क्यों हमें revise नहीं करना है? Because your MU resistance is coming to be greater than this. So our assumption this is coming to be right for this question. क्यों हमें कितना आ रहा था area of steel?
सर प्रोवाइडेड वाला कि रिक्वायर्ड जो हमें
Required. कितना आ रहा था?
प्रोवाइड किया 4019.
नहीं required कितना था पहले?
3692.93.
3692.93.
93.
हम प्रोवाइड कितना किया हमने जब हमने 4-5 बार किए 32 mm के?
4019.2.
4019.2.
19.
तो ये हमने
0.2.
प्रोवाइड किया.
Yes, sir.
So this is okay. We do not need to revise this. Based on this, that MUR is greater than MU, and further DF is less than XU is less than XU max. So your design is then coming to be under reinforced. And further, DF by XU is less than 1 and greater than 0.43. There is no need of revising this design. So we have solved this question. That's what we were required to do in this question, that we had to determine the value of area of steel, and we have already provided the area of steel. Now if you want to